Hello guys, welcome back to lecture series on a linear algebra. Myself Dr. Sognesh Shinde, and we are here back with some of important concept from consistency of a matrix. Okay, so without further ado, let's get dive into our today's lecture. We first of all understand what is the mean by consistent system and inconsistent system. Okay, mostly we refer consistent system in the term of consistency of matrix. Okay, so like we get the question like find out the consistency of matrix, whether the matrix is a consistent or matrix is a inconsistent. Okay, consistent, that we have to define here. Okay, so consistent system. Okay, consistent system means, or consistency of the matrix means, the matrix or the system which has a solution. Okay, let me write the system which has a solution. So make sure that guys, solution may be unique or may be infinite, it doesn't matter, or many more, it doesn't matter, but solution need to be there. Okay, so we mostly have a solution as a unique here. After that, infinitely many solution, or many more solution. Okay, yes, the system which has solution. Okay, and inconsistent means it is exact opposite of which, the system which do not have solution. Okay, the system which do not have solution. Okay, the system which does not have solution. Okay, have solution, the system which does not have solution called inconsistent. Okay, that means here we have only one option with left, which is a no solution. Inconsistent system means which has a no solution. Okay, and consistent system means which has a unique or infinitely many solution. Okay, yes, so let's continue some more points. So guys, we have one more theorem, important theorem, which is a Rouches theorem. Okay, Rouches, Rouches theorem, important here in a linear algebra. Okay, what is the Rouches theorem? Says that the system ax which is equal to b. Okay, the system ax which is equal to b. Okay, the system, we write a into x which is equal to b by using our given linear equation. Okay, yes, this system is consistent, this is a consistent. Okay, when this system is a consistent, whenever we write rank of matrix A which is equal to rank of matrix A over B, that means augmented matrix, that means coefficient matrix rank and augmented matrix rank, if both are equal, then we say that system is a consistent, or that means system has a solution. Maybe it is a unique or infinitely, we don't know, but there is a definitely solution available. Okay, so what if rank of A not equal to rank of augmented matrix A over B? Okay, if this is not equal, this implies no solution to our system. Okay, that we say that no solution to our given matrix. Okay, I hope you all have understood. A is a coefficient matrix and A over B is a augmented matrix. Okay, that I already explained in my last lecture. Okay, yes, so I hope you all have understood Rouches theorem, consistency and inconsistency of the system. Okay, so we are looking the solution, how the solution exists for the homogeneous or non-homogeneous system. Okay, let me explain for the non-homogeneous system. Okay, I'm gonna explain to you all first of all a solution for non-homogeneous equation, and then we go for the homogeneous system. So we are going to learn non-homogeneous system and their solution. Okay, how the solution it is look like for the non-homogeneous system. Okay, so we know that non-homogeneous system is A into x which is equal to b. Okay, A into x is a B, and B which is equal to Z, but Z not equal to null matrix. Okay, okay, this one is the non-homogeneous system. Okay, B which is equal to Z, but Z should be not null matrix. Okay, that means we want the B as non-zero matrix. Okay, yes. So here matrix A matrix is having order m by n. Okay, A is a matrix which is having order m by n, and augmented matrix. Okay, augmented matrix. Okay, augmented matrix. So what is the augmented matrix for this one? We write augmented matrix as a m. Okay, write down just as call augmented matrix as a m. Okay, and how we define augmented matrix? Matrix A over B. This one is the augmented matrix. Okay, yes. Now we are working on the solution. Okay, solution for the non-homogeneous system. How the solution it comes. Okay, so first we know that rank of this matrix A and rank of M. Rank of matrix A and rank of M. M means M is an augmented matrix over here. Don't forget. Okay. Now M is an augmented matrix. If rank of matrix A and the rank of augmented matrix M both are not equal. Okay, both are not equal. That means we do not have any solution. That means there exists only no solution. Okay, there exists only no solution. Okay, yes, that means the system is inconsistent. Okay, the system is inconsistent. Okay, I hope you all have understood. The system inconsistent means matrix which do not have solution. Okay, and we are writing one more condition. It is a very important condition. Okay, that means vector we cannot write in the linear combination of v1 v2 v3. Okay, so we cannot okay, we can't write a linear combination of v1 v2 v3 up to v3. Okay, v3 and so on. Okay, so that means if a matrix do not have solution, that means that matrix can be written in the linear combination of it's v1 v2 v3. Okay, yes, so that means it is very easy to define. Okay, yes, so by using rows and column, m is a row and n is a column, by using row and column we are going to define whether the solution exists or not. Okay, yes. And always remember that, guys, determinant of any matrix. Okay, I'm adding some of the important concept in the middle here. Determinant of A is a non-zero. Okay, that means matrix is a non-singular or invertible matrix. Okay, the matrix is a invertible. This implies unique solution exists. Unique solution exists. Okay, and determinant of a matrix A which is equal to 0, this implies infinite solution. Okay, remember these are the short point, guys. I'm gonna explain these points with some of the standard examples in our subsequent lectures, but right now you all need to know these conditions. Okay, yes. So now we are looking our solution with the orders of a matrix. Okay, m by n, it is a order over here. Okay, so let's get to find out how the order it is look like. Okay, consider that we have next point, rank of matrix A. This is the rank of matrix A, which is we are looking for this system only, non-homogeneous. Okay, rank of matrix A we write which is equal to rank of a matrix M, means rank of a coefficient matrix which is equal to rank of augmented matrix. Okay, and which is equal to n. And what is this n? This n is a column. Okay, column for matrix A, it is n is a column, n it is coming from here. Okay, this is a n. Okay, yes, if a rank of matrix A which is equal to rank of augmented matrix M which is equal to n. Okay, then we say that given system has unique solution. unique solution. And if it has a unique solution, that means consistent. Actually it has a solution, something solution exists means consistent. Okay, okay, consistent. Okay, if the matrix is a consistent having unique solution, in other language we call it as this one is the linearly independent. Okay, li, the matrix which we have is the linearly independent. Okay, okay, linearly independent means we can write the any vector v in the linear combination of some another variables. Okay, so we write the call it as a linearly independent. Okay, just for few days keep it on hold. Once we complete linearly independence, you come to understand that one easily. Okay, this one is a linearly independent. Yes, now, okay, n means what we call this n as a number of unknown also, or number of column. Okay, if you want n, where n is a number of unknown, or we can write number of n is a number of unknowns or number of columns that I already explained. Okay, yes. Yes, so we go for the next. If the rank of A and rank of augmented matrix both are equal, but it is smaller than n. Okay, then what we get? Okay, let me explain here. Next point, rank of a matrix A which is equal to rank of augmented matrix m. Okay, their ranks are equal but smaller than n. Okay, the rank is smaller than n. Then how we write their solution? Okay, n is a number of unknown or number of column, remember. Okay, that means which has infinitely many solution. Okay, or more than one solution. System has infinitely many solutions, or more than one but not unique solution. Okay, infinitely many solution or more than one. Okay, but not unique. So if it has at least a solution present, then we call it as the system is consistent. System it is consistent. Okay, and always remember that it has always non-trivial solution. Okay, non-trivial solution, that means zero it is not present there. Okay, it is a non-trivial solution, and whenever we are having non-trivial solution present, we call it as the linearly dependent. Okay, given system is linearly dependent. Okay, LD, linearly dependent. So need to remember these points, they are very important, guys. I made these short points just for your better understanding. Okay, I hope you all have understood everything here. Okay, yes. Now this one is like a m by n matrix. Okay, maybe m and m by n. Okay, maybe this one is a square matrix or non-square matrix. If it is a square matrix, then it is okay, m and n with will work both same. Okay, so what happen if, next point, what happen if m and n row and columns are the same? That means matrix is a square matrix. Okay, always remember that this system has unique solution if m and n, okay, rows and columns are the same. That means which has a unique solution, or maybe no solution, or maybe infinitely many solution. Infinitely many solution. Okay, these are the three options available when m which is equal to n present. Okay, so whenever m is bigger than n, that means number of rows is bigger than number of column. That means 4 by 2 matrix, 3 by 2 matrix, 5 by 3 matrix, like this matrix. Okay, whenever rows are bigger than column, okay, which has the same condition. Okay, it can has a unique solution, maybe it has no solution, or maybe it has infinitely many solution. Infinitely many solution. Okay, yes, if m is bigger than n. But the main condition matters when m which is smaller than n. Okay, when m is smaller than n, that means number of rows is smaller than number of column, okay, m less than n. So in this case system do not have unique solution, do not have, doesn't have, okay, does not have unique solution. Okay, system does not have unique solution when your rows are smaller than column. Okay, this one is first point. Second point, maybe it has no solution, or maybe it has infinitely many solution. Maybe it has infinitely many solution. Okay, see that guys, these are the condition which hold here for rows and column. Okay, so I hope you all have understood how the system of a matrix it works. Okay, these are the solution when we have non-homogeneous system. Okay, this one is all the solution guys whenever we have non-homogeneous system. I hope you all have understood this entire process up to here. Okay, yes, and similar with the condition, we have only one condition present for the homogeneous system. Okay, let me explain for the homogeneous system now guys. We have homogeneous system now. Okay, so homogeneous system it defined as x which is equal to b, where b which is equal to z, and z can be null matrix. Okay, z it is a null matrix. So always remember that whenever you have homogeneous system, it is a very important remark, whenever you have homogeneous system, we do not have any option like a no solution. That means our system has always solution. What is the important point? I'm writing this one. This system is homogeneous system. Okay, has always solution. The system has system is homogeneous system. EHS means homogeneous system has always solution. Okay, yes, always solution exists. That means no solution never exist. No solution never exist. Okay, that means no solution option is not there. Okay, yes, we have always solution. Okay, maybe zero can be included into the solution. Zero included, zero may included, zero may included. Okay, maybe zero it is a part of solution, but the solution it is always exist. Okay, yes, so if solution always exist means homogeneous system always consistent, always consistent. System is always consistent. Okay, that means if the system has a solution, that means system is always consistent. Okay, yes, so that means we do not have no solution available here. Okay, so what we can do, we will delete what, wherever no solution you will find. Okay, delete that no solution, delete that no solution, delete that one no solution. Okay, after delete this no solution. Okay, so wherever you will get the no solution here into the non-homogeneous system, delete that one, remaining left over part it goes to homogeneous system. Okay, just only the remember homogeneous system it is having always solution, no solution part is not there. Okay, for homogeneous system, but for non-homogeneous system we have unique solution, infinitely many solution, or more than one solution, or no solution also. Okay, for non-homogeneous system, but for the homogeneous system we don't have no solution. So the concept which we have learned from the non-homogeneous system, delete no solution everywhere, remaining left over all the part it goes to the homogeneous system. Okay, I hope guys you all have understood. Okay, you all have understood entire part here in my today's lecture. It's nothing difficult here guys. Okay, that is very easy part. Okay, that we learn for the homogeneous and non-homogeneous system. Okay, so in our next lecture guys, I'm gonna explain to you all some of the example. Okay, some of the example in our next lecture. Okay, that's it here for today's lecture. I hope you all have understood everything here into my today's lecture. Even if you found anything difficult guys, let me know in my comment solution. Okay, yes, so We'll see next part into our next lecture, some of the examples. So that's it here for my today's lecture. Thank you all. Thank you for my today's lecture.